Hello everyone, welcome to interview preparation. You might have heard about the solid principles. There is a hot topic and a key question that might pop up in your interview. So today we are going to break down this principle and make sure you are ready to impress. So let's dive in and get solid. What are solid principles? The solid principles are a set of 5 principles intended to make software designs more understandable, flexible, maintainable, easier to manage and adopt over time. By adhering to the solid principle, developer can reduce the risk of introducing bugs and improve the overall quality of their code. This video explore each of the 5 principles and their significance in the software development. The first principle is SRP, the single responsibility principle that states that a class should have only one reason to change, meaning it should have only one job or responsibility. This principle encourages developer to break down complex classes into smaller ones, into more manageable ones, each focused on a specific task. By doing so, the code becomes easier to understand, test, and maintain. Let's check the example. Imagine if you have a user service class. The class should focus solely on the user related operation like registering or creating the user. Simple, right? But what if you also need to send email notification like welcome emails when a new user signs up? Here's where the single responsibility principle comes in. Instead of merging the email functionality into user service, you can create separate email service. This way, the user service handle user operations and the email service take care of sending emails. By keeping this responsibility separate, your code becomes cleaner, more maintainable, and easier to understand. Plus, if you ever need to change how emails are sent, you only need to update the email service, not the user service. Hope that makes sense. Let's move on to the next principle. The second principle is OCP, that is, Open Closed Principle. The open closed principle asserts that software entities such as classes, modules, and functions should be open for extension but closed for modification. This means that the behavior of module can be extended without altering the existing code. By following this principle, developer can introduce new feature or changes without risking the stability of an existing system, leading to a more robust and adaptable code base. Let's see the example. Imagine if you have a payment service that currently supports the payment via credit card and PayPal both. Now, you want to add support for any new other service or modify the existing PayPal service. This will create a risk of bug if all the services are in same component, right? Instead, you can create a separate PayPal and a credit card service class that extends the payment service. This way, your original payment service remains unchanged and it will open for extension but close for modification. By allowing this principle, you make your code more flexible and easier to maintain. Adding new payment methods in the future becomes a breeze. Just create a new class for each method without touching the existing code. Let's check the next principle. The third principle is LSP, the Liskov substitution principle. The LSP principle states that the object of a superclass should be replaceable with the object of a subclass without affecting the correctness of the program. This principle emphasizes on the importance of inheritance and polymorphism in object-oriented design. By ensuring that subclasses are adhere to the expected behavior of their superclasses, developers can create more reliable and predictable system. Let's see the example. Imagine if you have a rectangle class and a square class that extends the rectangle. At first glance, it might seem logical when a square is a type of rectangle. But here's the catch. If you set the width of a square it should automatically set as a height to the same value, and vice versa. This behavior can violate the expectation of how a rectangle should work. To adhere to LSP, let's introduce an interface called shape with a single property called area. Now, both rectangle and square can implement this interface and define their own ways to calculate the area. This way, you can use rectangle and squares interchangeably without breaking the expected behavior. Each shape class handles its own specific, ensuring that substituting the one for another doesn't lead to the unexpected result. The fourth principle, which is ISP, Interface Segregation Principle. The ISP principle suggests that no client should be forced to depend on the method it does not use. This principle advocates for creating smaller, more specific interfaces rather than larger and general purpose ones. By doing so, developer can reduce the impact of change and make it easier for clients to implement only the functionality they need, resulting in cleaner and more efficient code. Let's see the example. Imagine if you have an interface called machine with the method for both printing and scanning. If a printer class implements both interface, it would be forced to include both print and scan method, even if it only need to print. This can lead to the unnecessary complexity and unused code. To follow the ISP, we can split the large interface into two specific interfaces, printer and scanner. Now, a basic printer class can only implement the printer interface, focusing solely on the printing task. On the other hand, the multifunctional printer can implement both printer and scanner interfaces, handling both printing and scanning as needed. By doing this, we can ensure that classes only implement the method they actually need, making the code cleaner, more modular, and easier to maintain. Now, let's check the fifth and last principle, which is DIP. The dependency inversion principle states the high level module should not depend on the low level modules. Both should be dependent on the abstraction. Additionally, the abstraction should not depend on details, and the details should be depend on the abstraction. This principle encourages developer to rely on interfaces or abstract classes rather than concrete implementations, promoting loose coupling and enhancing the flexibility of the system. Let's see the example. Imagine if you have a user service class that directly depends on the concrete email service. This setup can make your code rigid and hard to maintain if you ever need to change the email service. You will have to modify the user service class as well, which isn't ideal. To follow the DIP, we introduce an abstract notification service interface. The user service will depend on the interface rather than the concrete class. This way, you can easily swap out the different notification service without changing the user service. By depending on the abstract notification interface, user service become more flexible and easier to maintain. You can now use any class that implements notification service without modifying the user service. The solid principles are essential for creating high quality software that is easy to maintain and extend. Embracing the solid principle ultimately lead to the more robust and adaptable software solution that evolve with the changing requirements. But let's talk about some cons of the solid principle also. First is initial learning curve. When you are first getting started with the solid, it feels a bit overwhelming. There is a lot to learn and understand, which can be daunting for beginners. But don't worry, with practice, it gets easier. There is a potential risk of over engineering sometimes. In an effort to strictly follow solid principle, you might end up over engineering your solution. This means the adding unnecessary complexity to your code, which can make it harder to maintain and understand. Keep it simple and only apply principles where they truly add value. The last thing is it has more time investment. Implementing solid principle can add more time initially. Designing your code to be flexible and maintain requires a careful planning. However, the investment often pays off a long run with more robust and adaptable code. By now, you should have a solid understanding of the benefits of the solid principle. Thanks for watching. Hope you find this video helpful. Please like, share, and subscribe to the interview preparation for more awesome content like this. Also, you can check these cool videos. Your support means a lot. Happy learning!